Welcome. What I'd like to do is show you how to graph this exponential function. So the first thing, before I even start graphing exponential functions or even trying to do any kind of graphing, I want to understand what we like to call the parent graph and what exactly that looks like. So what I'm going to do is I'm going to draw up the parent graph for you. And the parent graph of an exponential function crosses at 1 and looks something like this. And that parent graph is going to be any number raised to your variable. So here's going to be your number. It could be anything. In this case, it's 2. And then you're going to have your input value, which is your variable, is also going to determine it. So there's going to be your y-axis, and that's your x-axis, where a can represent any number. So we know that right now it's going to cross at 0, and why does it cross at 0? Or I'm sorry, why does it cross at 0, 1? Well, the reason it crosses at 0, 1 is because if you were to put a 0 in for x, you'd have a to the 0, and we know any number, doesn't matter what a is, any number raised to the 0 is going to equal 1. So what I like to do when I'm graphing an exponential is I want to figure out where is it going to cross the y-axis, and then also what I'm going to do is I'm going to choose a point to the left and choose a point to the right of that intercept to kind of see where this pattern and behavior is for the graph. So the first thing we can do is always determine what the y-intercept is, see where this graph is crossing. So we know at the y-intercept, I have a little graph here, the y-intercept is when x equals 0. So I'm going to, I got a little room here, I'll erase that parent graph here. If I'm going to kind of create a table, we have x and y. Let's figure out first what the y-intercept is. So that means x equals 0. So when x equals 0, what is our y value equal? Well, we'll have 2 times 2 raised to the 0 power. Well, 2 to the 0 power we know is going to equal 1. 1 times 2 equals 2. So now I'll simply go ahead and graph this. I'll go to 0, 2. And you'll see by my graph, on the x-axis I'm going by 1. And my y-axis I'm going by 2 for a very good reason, as you'll see in a second. So now we need to, let's pick a point to the left and pick a point to the right of my y-axis just so we can kind of get a behavior of it. See if it's going to behave like my parent graph or if there's something different. So let's pick x equals -1. All right, actually, you know what? Let's pick x equals -2. Okay, so when I'm going to graph this, so now I have y equals 2 times 2 negative squared. Well, one thing we need to remember about 2 to the -2nd power, that is the same thing as 2 times 1 over 2 squared. Well, 1 over 2 squared is going to be 1/4, and 2 over 1/4 equals 1/2. So when x equals -2, y equals 1/2. And then let's look at what happens if x equals +2. So if I plug in a +2 here, and I write y equals 2 times 2 to the +2nd power. Well, 2 to the 2nd power is 4. 4 times 2 is going to equal 8. So now what I'm simply going to do is let's graph these. Now if here's 2, 1 would be half there, and so a half would be half of that. So at -2, 1/2 is roughly about right there. And then at 2, 8 is going to be over 2, up 8. 2, 4, 6, 8. And you can see right now this graph automatically follows along the pattern of my parent graph. And one thing for us to notice is you can see how the steepness gets higher and higher and higher as my values go up, and it keeps on getting closer and closer to the 0. So that's how you graph your exponential y equals 2 times 2x. Thanks.